Auditing in a computer environment has been drastically critical, especially nowadays that most business transactions are done through online platforms due to hundreds or thousands of transactions per day recorded in the database of the entity. How come that all of these are accurately reflected in their financial statements? To answer this query, audit software plays a vital role for auditors to examine the reliability of the data entering the database of the client, and it also helps auditor detect the malicious activity intentionally or unintentionally being committed by the management. Good day everyone, and welcome to our group presentation. We will be presenting Picalo 4.21, an audit software that we will be using to audit the client's data. We will be explaining what this software is, why it is suitable to be used as CAAT, and also what are its features and functionalities and how can it be used as an audit software. Let's define first what is Picalo. Picalo is an analytical data app suitable for auditors, fraud investigators, data miners, and other analytical data. The focus of the Picalo application is on fraud detection, corruption, and to get data from company databases. Picalo is also the basis for an automated fraud detection system. This application can be equated even the claims of the maker are in some ways superior when compared to other commercial-based CAAT applications such as ACL or IDEA, which run on the Windows platform. Project Picalo was started in 2003 by Conan C. Albrecht. Question may arise that why not to use a spreadsheet application such as MS Excel or OpenOffice Calc to perform the data analysis? The answer is MS Excel or OpenOffice Calc applications can be used for data analysis, but these spreadsheet applications have limitations on the amount of data that can be analyzed. Such limitation imposed is around 65,000 rows of data, while Picalo or other similar CAAT applications can handle up to millions of data.
Menu and toolbar. The Picalo menu options and related toolbar buttons provide access to dialogues that guide you through various Picalo functions. Each time you select an option from the menu, Picalo shows you the related command in the shell. In fact, the menus and dialogues actually just construct Picalo commands and run them for you in the shell. The object tree. The object tree keeps track of all database connections and tables created in each session. Double-clicking in a table in the list brings up a spreadsheet view in the tabs section on the right. Note that tables in the object tree are not automatically saved and are deleted when the program closes. This is done because many routines create hundreds or even thousands of sub-tables. Saving each of these to disk is not practical or desirable. Be sure to save the tables you wish to use again. Table or script tabs. The main section of the screen is a tab browser of the tables and scripts you have open. Tables show in a spreadsheet-like view. You can use this view to add, remove, modify columns and types, edit cells values, filter data, and view data. Scripts show in editor files and have the typical commands of cut, copy, paste, undo, and redo. Shell, command log, and script output. The shell allows you to type commands one at a time to produce results like running a script one line at a time. In addition, when you run a full script in Picalo, all of the variables created in the script are available in the shell at its completion. This allows you to perform additional commands or inspect result data without having to rerun the entire procedure. Everything you do with the Picalo menu and dialogues just translates to a call in the shell. As you navigate the program dialogues, watch the shell to see how Picalo is doing its work. The interface and the shell are two-way, meaning that anything you change in the interface, such as modifying a cell value in a spreadsheet view, also changes in the shell variables. In like manner, anything you change in the shell variables is immediately reflected in the interface. The shell is an excellent place to perform ad hoc analysis or to test commands.
In using Picalo as CAAT, users will have tables made up of different types of columns similar to a database. One of its main goals is to make relational databases easier to use. Once a user has a table, he can add, move, or delete columns, work with notes, select and group records in various ways, and run analysis on tables. Picalo includes adapters for frequently used database types, and it provides a query objects that makes queries look the same as regular tables. If the user is using relational databases, delimited files, EBCDIC files, MS Excel files, log files, text files, and other heterogeneous datasets, Picalo has optional project objects that store tables in the ZOP object DB file. Project allows Picalo to work with essentially unlimited amount of data. Here are the examples of use of Picalo.
To analyze financial data, employee data, and purchasing systems for errors and fraud. To import Excel, XML, EBCDIC, CSV, and TSV files into the database. Interactively analyzes network events, web server logs, and system login data. Import email into a relational or text-based database. Embedding control and testing fraud routinely on production machines.
Here are some of the information that users ought to know before using Picalo. Users can use Picalo for free and make code improvements and share it again with the community. Picalo has no guarantees. There are no guarantees about anything that is done within Picalo. It is possible that this software can eat up user data or even damage the hard drive. All risks are your personal responsibility. The users must release any additions to Picalo under GPL or General Public License. Picalo's program code cannot be included or used in any of those products that are licensed other than by the GPL. This time, let us look specifically at the menus and tools of Picalo audit software.
File menu. The file menu provides manipulation routines for first tables and then databases. Rows and columns can be added to tables. Tables properties like column types can be modified. Database connections can be created. And database queries resulting in tables can be run. Also, preferences or options for Picalo can be set in this menu. Edit menu. The edit menu contains the standard functions and features of most edit menus such as copy, cut, paste, find, replace, and etc. Data menu. The data menu provides functions that manipulate the data within tables. Different methods of stratification allow you to separate a table into a list of subtables. For example, you should separate a sales transaction table into separate tables for each sales clerk. Summarization allows you to recombine stratified tables using summary functions like sum, average, standard deviation, counts, and so forth. Summarization is useful to smooth the time axis during trending. Calculate the total purchases per purchaser during the period, or find which vendors are being used the most. Summarization is similar to group by in structured query language. The join options allow you to join tables together. Picalo's join features are much slower than database query joining, but they are much more powerful and flexible. For example, rather than simply joining where values match, Picalo can join tables based on text matching and custom expressions. With custom expressions, the ways you can join tables are limited only by your creativity. Analyze menu. The Analyze menu provides functions that run specific analysis. The first set of options on this menu provides initial views into datasets. This should when you first look at a dataset. Descriptives provides basic statistical descriptives on a table like counts, standard deviations, and column totals. Digital analysis uses Benford's law of numbers to evaluate whether columns values are natural or not. To find submenu provides audit procedures of finding unordered values, duplicate values in columns, and gaps in sequence. These functions are useful in discovering duplicate invoices or payments, missing documents, or sorting problems. The Find submenu also helps you to find matching and non-matching columns in tables. While SQL matches records easily, it only partially supports non-matching. In addition, matching does not join tables together. It only highlights matching records. An example of non-matching analysis is to find vendors used for purchases who were not approved vendors. Finding the rows in the purchases file that values in the approved vendor file highlights these transactions. The Select submenu allows you to select certain rows from tables to analyze. It is useful to filter tables before analysis and to find within tables. The Outliers submenu helps you to discover outliers in record sets. While many methods of finding outliers exist, the Z-score calculation is one of the simplest and best. With these options, you can add a Z-score column, select outliers, and select non-outliers. The Trending menu provides different methods of discovering the direction of a trend. While any human being can look at a graph trend and know its direction, these methods allow the computer to discover direction. This is useful when you have thousands of trends to analyze and want the computer to do the preliminary analysis for you. For example, suppose all of your employees have corporate credit cards. You want to discover employees who exhibit an increasing trend in spending over a 3-month period. Expressions. Expressions are mathematical formulas that run calculations on rows, tables, or columns. Expressions are given in Picalo as strings, such as ID plus 1. Expressions are used to define the value of a new calculated column or to summarize a subgroup of records in a table. They are used in most Picalo functions. Expressions provide you with total flexibility and control in joining, selecting, stratifying, and most other analysis routines in Picalo. Since expressions can be more difficult to write, Picalo also includes shortcuts to expression writing such as matching by value or stratifying by date. Detectlets menu. Picalo's detectlets are one of its greatest strengths. Detectlets are wizard-driven, step-by-step guides that walk you through different analyses. Upon startup, Picalo automatically discovers the detectlet modules you've installed and makes them available on this menu. If you want to do powerful analysis with a simple wizard interface, detectlets are the solution.
In Tools menu, there are Expression Builder. This is an analytics utility that helps you create expressions. The Expression Builder is available wherever a user-defined expression can be created. Detectlets. These are the following: Install new library, run script in Detectlet Wizard, Time Engine, Bid Rigging, which are bid summary by vendor, and bids with identical line item amounts. Bids with line item that are exact percentage of one another, last bidder winner, multiple purchases slightly under threshold, verify bid total with line items total, winning bid not lowest bid, winning bid not lowest bid summary by vendor, verify bid total with line items total, winning bid not lowest bid, winning bid not lowest bid summary by vendor, phantom vendors, which are compare employees with vendors by fuzzy match, create Venford's numbers, find groups of fabricated numbers, find vendors with sequential invoices, paid vendors have mail drop address, paid vendors not qualified vendors, and paid vendors not qualified vendors summary by vendor. For Help menu, there are Check for Updates, Online Python Tutorial, Introductory Picalo Manual, Picalo Cookbook, Advanced Picalo Manual, README.txt, License.txt, Show Hint, and About.
What are Picalo's limitations? Picalo's has several limitations, a few of which are listed here. First, Picalo may still have bugs, especially in the GUI, that have not been found by the users. You should always double-check your analysis, print control totals, and list intermediate results to ensure that your analysis ran the way you expect, although you should do this regardless of the software package. Next is Picalo has no warranty, support, or guarantee. It is released with the hopes that it will be useful, but you are responsible for anything it does to your computer, your data, or anything else. Although there is no formal support, open source projects like Picalo have shown that user support for one another is usually superior than company support. And last, unless you write scripts to use database results intelligently, Picalo loads all data into memory for analysis. Your computer's memory may limit the number of records you can analyze. In practical use, Picalo has been shown to analyze millions of records easily, so this limit is quite high.
Let's go to the audit proper. Our client is CBay Superstore Company. CBay Superstore Company was established in 2000 by Vicente de la Cruz. The superstore sold a wide variety of products including various essential goods such as groceries, appliances, household products, school and office supplies, and many more. Due to a voluminous transaction, Vicente set up a computer network and a system assisted the automation of the company's business processes. CBay and our audit team discuss the services needed in the engagement. The firm then negotiate on the services to be rendered, as well as the price and the time frame for conducting the audit.
Duplicate and erroneous payment are always challenged within any accounts payable department. The primary challenge is the detection of the issue before the payment is processed. An additional challenge is the identification of the cause of the error and then the implementation needed. This audit tool can provide necessary procedure to identify duplicates and detect a process issues that create risk for erroneous payment. But how duplicate and erroneous payment identified? In Find submenu, it provides audit procedure findings for inaccurate values in column. These functions are very useful in discovering duplicate invoices. So in this case, we have 1,000 of transaction, and out of this transaction, we want to identify if there is any possible duplicate in this table. So first, we click the Analyze menu. After that, just pick the Find option and click the Duplicate button. As you could see on this mini table, it contains all the variables included on the previous table, which is the product ID, supplier ID, invoice code, total, and date. You could select one or more items that you want to check for duplicates. So I would choose product ID, supplier ID, invoice code, total. I will not choose date because in some cases, there are invoices that are duplicate but issued in different date. To complete this task, just rename the table. Simply fill in this box and I will type here, duplicate invoices. Select OK. So as you can see, there are items that have been duplicated, and the last column indicate the specific row that is identical. So as we check it on the previous table, row 21 and row 26 are identical. So as we check it, the product ID, supplier ID, invoice code, and the total are indeed entered twice, but they are issued on a different date. And same goes with rows 58 and 73. The product ID, supplier ID, invoice code, total. This might have been duplicated but issued on a different date. This duplicate payment may cause on entities' accounts payable process that do not detect in prior payments. This audit tool provides the foundation for the detection of double payment that leads to inaccurate records.
It is very important for a sales transaction to be recorded correctly. In this matter, our audit objective is to audit whether the calculation of sales is accurate and normal. So the audit procedures would be: first, go to the Table Properties dialog box, add a column, then rename it. I want the column name as Testing Gross Sales. Then the type is calculated field, so I can add an expression or a formula here at Expression Builder. So to test the accuracy of the sales, the total sales, we need to multiply the units sold to the sales price. Then validate the expression. Then okay. Then save. So here it is, the testing amount of the units sold multiplied to sales price. Then let's also add a column. I'll name it variance. If there is a variance between the gross sales and the testing gross sales, so I want a calculated field to add the formula. So gross sales minus the testing gross sales, validate, then okay, then save. So here,
After calculating the variance, this next audit objective will support the accuracy assertion. So, earlier, we recalculate the mathematical accuracy of the client's data, which includes the total amount to be collected or the gross sales. This is to ensure that the transactions are accurately recorded. So, here are the line items that we recalculate earlier versus this is the amount recorded by the client. So, we will move on to make comparison of gross sales and testing gross sales that we recalculated earlier. We would like to see here if multiplying the quantity by the price produces the accurate total, and if every item on the gross sales provides the right amount. First, we go to Analyze menu and pick the Find button. After that, just click the non-matching per value. So here, there is a mini table appears, and as you could see, there is a first table and second table that you want to compare. So you could select different table depending on what item you want to compare. But in this case, since the items that we want to check are in the same table, so we will just click the same. So just click sales. Next step is the match criteria. So as you could see here, there are 3 items or line items. So you could check 2 or more table or variables. But now, we only choose gross sales and testing gross sales. After that, just rename the new table, and I will put the name here as non-matching value. So if we click OK, and if the new table appears blank, that means that there is no item on testing gross sales that do not match against gross sales. Basically, it means that the record presented by clients are all correctly computed. So as we click OK, We could see here that there are items that we recalculated earlier, which is the testing gross sales that do not match against the client gross sales. So, the unit sold multiplied by the price, it should be 603,750, but what was recorded here is only 63,750. And same goes with the other items. All in all, there are 1, 2, 3, 4 items that are inaccurately computed. This audit tool is not only intended for this situation, so we could also use this for recalculating the amount paid to a vendor under expenditure cycle, like for example, in comparing whether the purchase order or total purchase order matches against the total contains on the receiving report and invoice issued by the vendor. So this audit tool provides us insight to detect the possible error and inaccurate calculation of amount. It is important because it could also detect the possible accounts that might have been overstated or understated. As a result, the auditor will be able to assess the potential areas of risk in a client process and develop a plan to address the areas with the greatest concern.
Another audit procedure is to audit total sales per segment for the purpose of verifying sales amount presented. I will be using pivot table feature for this objective. On the data menu, click pivot table command, then a dialog box will appear. I will select segment for the column and country for the rows. Calculation will be the summation of sales, and the result name is sales for the expression, then click OK. From here, we can now verify if the amounts presented is matched and correct with the database.
One of the activity in revenue cycle is collecting cash from customer. The next audit procedure is to determine whether the cash receipt date matches against the deposit date. This is to ensure that the recording of transactions are maintained in bank. The use of banking facility is guarantees that all monetary transactions are typically kept track of. So here are the transactions related to the audit procedure. We have the total of 1,686 transactions. The first column include cash receipt ID, amount, status, type, receipt date, and deposit date. Now, we want to see all the receipt date that matches against deposit date. The way I could test for this is the use of expression builder. So we click it, and after clicking it, as you could see, there is already existing function that are built in the software. In this case, I want to see all the receipt date that are equal or matches to the deposit date. So just double click the item that you want to test. And after that, click the double equal and click also the deposit date. I can validate everything before I run it. After this, just run set, and now it shows all the receipt date that are matches against deposit date. Now, in this case, we want to look for if there is a receipt date that do not match against deposit date. Same procedure. Just click the expression builder, double-click the item you want to test, and in this case, we click the exclamation point and equal to see those values that are not equal. Click the deposit date, validate, and OK. After clicking the set button, as you could see, there is a couple of cases where the receipt date do not match against deposit date. This test is necessary because cash and checks are highly vulnerable and prone to theft. Therefore, this procedure must take place to detect the possible fraud. She's a